Start recording. All right. I see me. I hear me. So welcome to Advanced Git. Raise your hand if you are here for Advanced Git. Awesome. Okay, so people in front. That's how we like it.
The prereq stuff? See the little prereqs thing? Nice.
So
Let's check it.
raise your hand if you can like type git lola in like a Git repository and like see something. Maybe something like this. Cool? Cool. Okay.
Did you do get Lola?
Is it alright if I move the television back just here?
Oh, got it. Okay, perfect.
Yeah, that'd be sweet because I can't see it.
Yeah, do what makes sense. I'm not from around here. Make it work.
I can use a marker.
Is that okay for you guys over there?
Yeah, would it be make sense to condense into one table?
Yeah.
And we could just make it
Yeah, come on, get in here close.
Are we sandwiching in, guys? Sandwiching on in?
I love this. Like students are solving problems for the instructor. I don't even need to think about where you go.
Do you want me to figure it out?
If
you like.
Hey, out of this spot, I've already done this. Sort of.
Wherever you can see the TV is fine with me. Do these tables move? Can we just drag one?
Tables are kind of a pain to move, I think.
Yeah.
Because they're like anchored into outlets and such.
All right. Well, that makes my whiteboarding hard because then it's to like half of your backs. Is there anything that I can wipe?
We can turn. We can turn.
It's yours, Swivel.
It's over.
I'll go grab it. I'll go grab it.
I'm Coach McGosh.
Okay, and then so you all have whiteboard tables. Do you have whiteboard markers?
Yeah.
Because I would like to do a labeling exercise. So grab a marker if you don't have one.
Damn. I know there's some, I know there's a shitload needing forms.
Blue one over there.
Pillaging 84 for the markers.
Here's blue one. Cash. Blue one. Chair.
Yeah. Would it make sense to slide the closer to this way since we're over here?
Yes,
I'd be happy to assist.
please. Go.
Till I unplug it.
Whiteboard City.
Oh, awesome! Thank you.
Nice.
Just now, does the TV turn back on?
Does everyone got one? Everyone else need one?
Do you know how to make this happen? Sorry, I guess I should have prepared for this.
Have you tried?
You don't have to yell. Alright, inside voices. Thank you.
I'll get the rest of this.
Adam, I can hear you through my headphones.
So, I'm glad you're back in basketball shorts. You're looking really fucking weird in those meetings.
Will this like auto detect? Okay.
Alright, No, I hit the power button twice.
Oh,
We're gonna get there, I swear.
Mike,
It's one of those days.
Right here?
Yeah, it was Casey sitting
Power.
there.
No, he moved. He's there. He's on the end now.
Oh boy, I think it's sandwiched between you two. I'm a lucky guy.
Nothing?
I don't know how to do that.
Here.
It was HDMI 3 is where it went.
Yeah.
So we can just go to that. I
Okay.
just got button happy there. Sorry about that.
All right. A bunch of programming students can, in fact, turn on a TV and connect it to a computer. And between you all have like, everyone got a whiteboard marker?
Yep.
Cool. All right. Then I guess. So let's go around. What did you hope to get out of this lesson, Casey?
I hope to understand a little bit more about branching and probably, just general collaboration and going in between branches and what happens kind of behind the scenes when I'm doing those things.
All right. So you just want to know more about branching, is what I heard. Sorry. What is your name?
I'm Adam.
Adam. Good to meet you. I'm Brent.
Good to meet you.
You must be 84.
No.
Wow. You're 75.
Yeah.
And I can't believe I haven't been in a class with you yet. So Adam, what did you hope to get out of this?
Anything more than add commit push, all the little, especially like the dash F stuff, or like moving files, anything more than the standard stuff that we do at the start.
Cool. Michael.
I'm a fucking mess when it goes beyond add commit push. Like if I accidentally commit and I need to like uncommit, like I know it's like reset, but it's like
This is the class for you. Yeah. Okay.
Everything gets really messy and tedious beyond that.
Chance.
Yep, same.
Same.
Deal, same deal.
What's your name?
Tim?
Tim. Yeah, we've met Tim.
I just thought it would be cool to do it 3 o'clock.
That is an acceptable answer. And sorry, one more time.
Brandon.
Brandon. Okay.
Yeah, I can't tell you how many times I've tried to reset and then end up just checking out a new branch and issuing a PR to myself.
Perfect. Usually I have to say like, no, I'm not going to teach you all of that because what this lesson is about is how Git works internally. And if you know this, you'll be able to figure all of that out. But actually, all of that is directly addressed by stuff that we're going to talk about today. So questions before we get into it?
And don't forget Colin and Jacob.
Oh, hey, yeah. What did you hope to get out of it? Now are you Kyle or Jacob?
I'm Colin.
Colin. Okay.
It's Jacob.
Okay.
And hi Colin. I would like specifically, I think it would just be really cool to learn how to do like collab stuff, like when you're working with a partner and you're both pushing to GitHub, and then when you want to like switch off and pull down stuff, like there's like merging conflict, like a whole bunch of weird stuff. So just to like figure out how to work with people.
This will get you like halfway there.
Okay.
We're only going to deal with a local repository today, but like your local repository really is just a copy of the other one. So like I think you can learn this and then apply that to
Okay.
So Jacob?
And then the same thing Paul said, but I'm going to start working on a project with my
Perfect.
G30 buddy, so hopefully be able to like work with him and never have to like watch YouTube videos to figure this out.
Yes, because this is going to video. I hope the last one was just like a picture of my Slack the entire time. So we're going to do a retake. All right, so let's go backwards. Jacob, would you mind reading the first objective?
Identify classes of graphs, rebates first merge.
All right, classes of graphs. Cool. Next one, Colin?
Yes. Predict the effects of Git on the DAG.
DAG. Who knows what a DAG is? Cool. All right, we're doing all right with this entry ticket thing. Brandon.
Use Git-Lola to visualize the DAG.
Sweet. And you all have that installed, so you've probably already maybe seen something like, oh, never mind. I'm not in a repository, you'll get to see it. We'll bring that up in a minute. Next, Tim.
Identify the parts of commit.
Oh, don't look at that yet. Oops, this was for the teacher. Explain advantages of rebase versus merge was the final one. So that is what we're going to do today, those things, and no cheating.
You never saw it.
Nope. Awesome, so install Git Lola. You have all done that already. So instead, let's jump to parts of a commit. So I would like you to take like, I don't know, 60 seconds and turn to your peer and you're going to talk. Together, I'd like you to write down the parts that you think are in a Git commit. So like non-technical, like just conceptually, like what information is there? You know, like you've looked at the Git log on GitHub, you've probably seen things like avatars or names or like. So just turn and talk and write.
So when you do, what do you think goes on?
You committing your body goes to your repository.
Files.
Oh, like the state of your repository or files.
What parts of the state are? Like, give me parts now. Was dash in?
Like the overall state.
Yeah, it's like right at 5 dash in.
Oh, just like, okay, they're just like your notes.
Like a mess.
Yeah.
Well, it's just like where everything's at, actual in the repository. There's paths to like the tree of files.
That's like your commit is like the command to do
When you commit to it, there's that.
previous commit. New commit. Like when you do like git commit, those are the two main things.
Oh, you mean without pushing?
Yes.
Like if you commit something, then commit something else?
Well,
Sure.
okay.
All right, let's give it like 30 more seconds. Just one thing. Have one thing in there.
No clue, bud. That's why I'm here, bud.
So we should put like the.
All right, cool. Jacob, what is one of the things that you and your pair came up with?
We didn't really understand the question fully, so we kind of just said what part, like what is a commit, like what do you, how do you do to get to that point? So there's like a stager of some kind. So you stage like what you've changed or what you've done in like some kind of project.
Your work, yes, like what you've done is like part of a commit. So specifically Git stores this as like all of the files that have changed. Many people often think this is like the deltas, like just the lines that have changed, and it's actually like every file you've changed like goes into the commit itself. So files, I'm gonna give you that one. Brandon, what did you?
Michael and I talked about, it mentioned state, like the state of your whole file, so it's tracking the changes, I guess.
Yeah, so kind of the same thing. Like
Yeah.
your state is the contents of your files.
Right.
Yeah. Chance and Tim, what did you get?
We had a few. We did name, email, message, timestamp, and then he brought up the additions and deletions.
Message, timestamp. Okay. So having heard all of that, can you guys think of any other things that go on a commit? Sorry, Adam.
Huh?
So seeing that these are some of the things that go on a commit, can you think of anything else
I'm looking at.
on the
I
way?
mean, I'm looking at documentation right now, but
I'll give you a clue.
what?
How would it know which commit it is? Know something unique about it.
Say what?
So like
Here.
every commit is unique,
Oh yeah.
so it needs to know about.
So that's why we researched this before we started.
All right, what do you got, Brandon?
Hashes.
Hashes. So it has an ID.
Mhm.
That is supposed to be a D somehow. ID, which is actually like a SHA-1 hash. Doesn't really matter. So you all watched the video on hash. Somebody tell me, like volunteers here, who knows, who thinks they could say, very high level, simply, what is a hashing function? What is a hash? Yes, Jacob.
Hash function just like is a way to find like an ID for where something goes, kind of like an index of some kind of data storage system.
Sort of. Anyone want to piggyback on that? Michael?
I believe it encrypts some data.
Yeah. So unlike encryption, like encryption doesn't lose anything. If I encrypt it, I can decrypt it again. So a unique property of a hash is that it's one way. It takes a bunch of data and like does some cryptographic stuff to it to come up with a number. Given that data, you always get that number. But you can't go the other way around. So it's a convenient way. So they usually see it something like ABF725, whatever. But like that is actually much longer. Gets this only showing you the first part of that. So that's like a 128-bit number. The nice thing about this is like it's more likely that like we'll all get hit by asteroids like simultaneously than like two of these ever end up having the same number. It's just that big. It's unfathomable. So it's a great thing to use as an ID because this also shows you another thing about a commit. Do you know what this is a hash of? Like the ID of the commit? Like what is the input to this hashing function that results in that number?
All of that. Yeah, it's just
All of that.
All of that. Yeah.
All of this, except for the ID, is actually part of the hash, which brings us to another property of Git commits. They're immutable. If you were to change the contents of the file, you'd come up with a new commit, so you could never change these things. It's like cryptographically impossible. But that brings us back to like one more thing, which is something that nobody's ever guessed yet. 0 through 2 parent IDs. So if I know my ID, and I know the ID of my parent, I can sort of like build a graph going like backwards in time, saying like I'm based on this, and that's based on this, and so on and so forth. So that's what's in a commit. Really all we need to worry about today is these parent IDs, these files, and really like this ID. The rest is just like some random stuff that went in there because it's handy. Yes. So, graph labeling. I would like to have an eraser. So I'm going to give you some words, and I'm going to give you some pictures, and I would like you to like draw on your tables these words and these pictures, and like point the word to what it is a picture of.
There's more right there on the table. You don't need a eraser. You don't have to yell. What's the shorter marker? I can go next door around.
Do you need to remember your name?
I'll be right back. Okay, I got one. Oh, dope, dude. Thanks, dude.
There's a shareable eraser.
You know. What's the objective?
We're gonna draw these things and
What's that about?
Oh, come on. This looks very
It's
complicated.
going to be like the most unintimidating, I hope,
Really?
graph
Does it
theory.
say this is complicated? Well, you can, you only have 5 chances to get it wrong.
All right, so looking at these pictures, write down yourself, like either draw this. It's probably best to draw it, honestly. I don't know. If you just want to like label, that's fine too. But like take a minute, talk to your pair, you get to work together, and figure out like which one of these do you think is a node, which is a list, which is a tree, which is a, then we start getting big words, but like, so let's talk about cyclic. Like, can anyone tell me what cyclic means?
goes in a cycle.
It has cycles. And so acyclic would be the opposite of that. There are no cycles in an acyclic. And these are arrows. Sorry, they're not an artist.
Let's start with those. Which one do you think would, out of the number?
So we're identifying the number to the
I think
title.
So if I thought node was number 3, I would be like
1?
3. Or I just draw it and write node next to it. However you want to do it.
Gotcha. What would a list look like? If you think about a list, what like graphical structure would look the most like a list out of those? What about a tree? Which leaves only 2 more things: the cyclical.
both of those are.
Well, like you said, those are arrows.
Oh, it's gonna be 5.
Although I think
And then
Oh, yeah.
dope, homie.
that's exactly what I think of when I think of
Yeah.
That's all.
Okay, 10 more seconds. Okay.
Is it Friday?
No.
Oh, jeez.
I have great songs. Just
Kidding.
Okay, reeling it in. This is hard to fit into an hour. Adam, did you get one of these?
Yeah, I think I got all of them.
all right, what's your favorite?
I mean, the easiest is gonna be list, probably, right?
Okay, so which number is a list?
1.
All right, a list is number 1. Can you describe your thinking there?
I just like, I don't know, it just visually looks like that. That's how you visually relate to it.
Exactly, like you've used for loops to like iterate over something like this. You've done linked lists, I think, where each one points to another one. So yeah, I would say that's a list. Anyone get anything different? Cool. Let's go for Tim. Sorry. Yeah, well, just name your favorite.
Number 4, I think number 4 is the acyclic graph.
And why? What is your reasoning behind that?
Like if you look at the parent node, it splits, and then it goes to like 2 separate nodes, and it goes back to like a different node, so it doesn't go back to itself.
Cool. Which is as opposed to Brandon. Do you know which one was the cyclic graph?
The number 5.
Number 5. Why?
Because it goes in a
Cycle.
cycle.
Yes. So this is like Back to the Future, right? Like you can't go back in time and like impregnate your mother and have yourself. Like this is.
We just went there.
Yeah, like why not teach using weird metaphors? So this is an important data structure, directed acyclic. Well, okay. What would I call it? Michael. Tree.
I got this.
Awesome. And why is it a tree?
It's just branching out.
Cool.
Because all of the other numbers have been taken.
That's a fair and honest assessment.
So these things are classes of graph. And so like you always want to go to the lowest class of things possible. So like all cyclic graphs can contain, like if you have a data structure for this, it can contain this. If you have a data structure for this, it can contain this. So these are like supersets going out. The simplest is a node. You get a bunch of nodes, got a list. There's things that you can do on lists that you can't do with trees. And there's things that you can do with trees that you can't do with DAGs. So this is often referred to as a directed acyclic graph. Last day. But this is very important for representing things that have to do with time. Because if you think about time, like nothing can ever reference a thing that happened in the future. And so Git cryptographically proves this. So this is all Git is a graph database, and it is of the order DAG, directed acyclic graph. This is what it looks like inside. And there are only nodes, which we call commits. Node equals commit. And there are tags, which equal a label, a pointer. Master. Tags. I'm going to call that pointers. We'll get into that in a moment. So these are the only 2 things you need to care about. Branches are just like a special form of tag that like automatically moves with you to point at the latest thing. Questions on any of this before we like get off of the whiteboard and like, well, we're going to go whiteboard screen, and see if we can predict, now knowing that behind Git is a graph database, what these commands are going to do to that database. Okay.
A great segue into telling us what DAG was.
Well, and then just to lighten the mood for a minute.
Yes.
Oh,
Oh, man.
where's the volume?
Then I'll do an impression. You like DAGs?
Sure, I like DAGs.
Yeah, I like DAGs. That's right.
If you-
Michael, really never done without you got AIDS.
It's probably not. It's what it's not.
Cool. Yeah, Git is a graph database. So like you ever like look to like do an LSLA and then see that .git folder like hanging out there and you're like, what the hell is in there? Let's make one. Oh, probably need to make this bigger. So look, I got a .git folder. That's weird. Why do I have that? I don't know. It's got a bunch of stuff in it. Heads, ref hooks. Like we could probably do like a 401 level Git lesson where we like you can actually just like use standard Linux commands to like take these things apart, extract them, and like find the IDs and like the folders that they point to. We're not going to talk about the structure of this graph database. You just need to believe that like in this .git folder is like the necessary files and folders to represent a DAG.
Question,
Yes.
what is LSLA do?
LS is list.
Right.
Dash L is like in a list format rather than like in a left to right, top to bottom format. And then A is all, because by default, if you just LS, it doesn't show anything that starts with a dot, because that's how Linux likes to like do hidden files. So you have all installed GitLola. Please don't type along with this. You can watch the video afterwards. We actually have an exercise you can, kind of bad exercise, but it's the script for all of this stuff. So you can like go back and do this later, or you can do it along with the video if you like. But predicting output, I've just initialized an empty Git repo. We know that because I have a .git folder. I've not done anything yet. If I type git lola, what will we see?
Nothing.
How do I draw nothing?
Yes. What if you see like you creating the Git folder? What you creating the-
I cleared it. It's gone.
There'll
Sorry.
be something for initializing the Git repo.
Remind me not to clear ever again because last time it saved my ass because I had this. Sorry, what were you saying?
I said it's gotta create a node when you initialize the repo, right?
Every commit is a node.
Oh,
I
right.
haven't made a commit yet. So I actually have an empty database with like nothing in it. Yes. You had something?
I'm scratching my head.
It's a tell. Playing poker. All right, so this is why you need like basic Linux commands. Like if I want to make a file, I can say touch and the name of that file. Let's make a README. But then, how do I show the contents of that file?
Cat
Nice.
or less.
Or less. Yep, valid answer. How do I put something into that file? So we're not leaving the terminal today.
You can use Vim or Nano.
You can use Echo too.
All right. How do I echo?
And then carrot right.
Uh,
Oh no, sorry, yeah, you do the quotes like message and then you do carrot right and then the file.
Cool. Yeah, exactly. README. So now if I cat my... Oh, I did this last time too. No explanation points and double quoted strings. Whatever. I'll fix this the easy way and just not be excited anymore. So if I do... So this is all stuff that you've done. Like Git consists of two parts. There's like the stuff in these folders here. And then there's this graph database. And then there's this weird like nether region, which is like the index, which is things that it's like tracking but haven't yet become part of a commit. So I think you've sort of been in files and index world, like you've gotten up to the commit level and you've done push and pull, but like I think the rest, there's like a chunk that's missing in there. So you should know like, what if I do git status, what's it gonna say?
You'll have a modified file, but it's not add, it's not tracked.
Okay, so what do I wanna do?
Add dash.
So now, what is the status of my file?
Tracked.
Tracked.
Staged.
Staged, yeah. Reviewing Git 101. Cool, and so then if I want to make a commit, I can do initial commit. Hey, no explanation points. So if I do git lola, what am I going to see? Michael.
A little star that gives you the first bit of the hash. And
You've been doing some git lola.
well, yeah, I tried it out.
Okay, so I'm not going to draw the stars because that's more time consuming than drawing this. So yeah, we're going to see, I was just going for this really, but you're going to see this and some tags pointed to it, yeah? Oh yeah, so you said the numbers, 1, B, F7, I don't know, whatever the hash is.
And a message.
That's the carrot was square.
That's a square.
It was a 10.
I hope what I see is something like head and master.
Oh,
Yeah.
yes.
Because it's showing you these are two tags. Head is a special tag that just represents whatever is checked out on your file system right now. So like if I want to go somewhere else, it's just a matter of moving that head tag to somewhere else. And then master is a branch that I'm on. So master, I said branches are special tags. Like as we continue to make more commits, head and master are going to go forward. But if we were to create just a git tag, it would just sit there forever. Like tags are for releases. Like, boom. This commit is and forever will be like v1. That's a tag. Most of the time you use branches. But they're the same thing. They just point at commits. And this is why branching is so light in Git. Like to check out a branch, it just goes to that pointer, like goes all the way back to the bottom, like starts dropping files on your file system until it gets back to where it is now. So branches are really lightweight. Like you don't have to worry about making them. I'm on a tangent. Get Lola, yay! And you're right, the message is on there too. Let's ignore. I don't know, maybe ignore the messages. Let's get a real. So I'm going to abbreviate head with an H and M for master. And what is the number for this? FE
11857.
7 with head and master pointed at it.
You can just call it the shop.
I can what?
Call that number the shop from now on. Is that correct?
Yeah, so this is the SHA, the ID. Okay, so yes.
Can you give us an example of like a hash function that you use to find that hash? Like what type of hash function are they using?
It is a SHA-1 hash, and if I hash this file using SHA-SUM, which I think is you just brew install, it will compute a number that is probably not that number because it's not just the contents of the file, it's the contents of the file plus all that other stuff. But you can use SHA-SUM to calculate this by yourself. Yes?
So, why, like, if I understand hashing correctly, there's also a SHA-256, which is a little more
Secure.
secure, right? There are more possibilities with it. Why not use that?
SHA-1 is a broken algorithm. Google cracked this. They're actually like, you can rewrite GIS histories now with like 24 hours of like supercomputer time because they cracked it. So it's still computationally intensive, but nowhere near so as more cryptographically secure later algorithms. The reason why is like SHA-1 is fast. Linus didn't need it to be that secure, and it wasn't cracked when he wrote Git.
Okay.
By the way, Linus Torvalds, same guy who wrote Linux, also wrote Git. It was actually fairly hilarious. He was like working with another provider, Bitbucket or something. Like all of the Linux source code was in there, and like he needed features that they didn't have. And they were like the only game in town at the time, and they're like, no, we won't add it. Pay us more. Linus was like, screw you. I bet I could do this in a weekend. And like wrote Git, and then like totally destroyed their market. Don't piss off Linus Torvalds is the moral of the story. All right, so I want to do something. What do I want to do? Let's have audience participation. We have a Git repository with a clean working directory, meaning no files have changed. I'm exactly matching what's in the graph database is exactly what's on my file system. If we had changed some files, this would be called a dirty working directory. And so you want to never like run your tests or push or pull or do anything with a dirty working directory. You always want to like git ignore, stash, or commit all of your changes. So that what head points at is actually what's going to be in the repo. Pro tip. Because if you run your tests and you have a dirty working directory and they pass, and then you were to just get push, like are you pushing the same thing that you just tested? Not so much. So that's our status. What do we want to do now?
Change the file.
Change the file. Okay. Let's echo some more stuff. Do we want to change it or do we want to? Doesn't matter. Okay. Hello 2 into, oh no, make a change into append to this file, db.txt. If I cat this, we should see both lines. We already talked about how to git add and git commit. If I type git Lola right now, what do we, well, hey, we're going to cold call this time. Think about this. Turn and talk to your partner. If I type git Lola, what will we see? I've just made a second commit. There's my command line up there. 60 seconds.
You got this?
So
Well,
notice
previous.
it's gonna say the first one, the first hash,
It'll be in
head
that
master, and then it's gonna say the next hash, and then like the message is saying.
So the new commit is on
Well,
top
that's
from
that's
bottom.
up.
See, this is where I get confused.
With the master beacon.
So
Yeah.
we're making just
Yes.
So heavy.
Add to current.
So if I made another.
Yes, you are right. On all of the above.
Yeah, it makes,
Yeah.
like another commit would be a new node, right? So what would that look like? I don't think you had the pre-rec.
Yeah, your
You didn't do any of that stuff.
first commits.
You just kind of
jumped in on this.
Okay, sorry. Yeah, I pulled you in. I violated my own entry ticket. You get a pass today. That is my bad as a teacher.
Fair and honest.
So
Okay.
yeah, I'll show head at last, because that is the head of your working tree.
Gotcha. You are the head.
So the head is correct at the top, and then
Yeah.
the master will be tags.
So it'll
where you're at.
it'll say head, because that's the working tree you're on, and whatever branch you're currently working in.
Okay, you sound confident, Adam. I'm gonna.
Brandon.
Fuck.
Adam's there.
Definitely don't sound confident.
You sound confident, Brandon. I'm gonna give you the opportunity to tell me what to draw here.
Yeah, so it's gonna show the hash, and then it's gonna say head and whatever branch you're working on, and your in this case it's gonna show your make a change commit. It's gonna be the hash of the make a change commit, and then head master, it's gonna have the make a change message, and then it's gonna show your previous hash and message below it.
So that was an excellent answer. I believe you got everything right, but did you calculate the SHA sum for me? Joking.
What?
Come on, I want the ID, damn it. 888521. 888521. Okay, cool.
A in there.
8521. What should I do next?
Make a new branch.
Where do we want to branch from? Here?
I don't know how to just throw stuff.
All right. Well, let's show that we can. Yeah. Why don't I do this one? Let's say we wanted to branch off of the initial commit. Yeah.
Okay.
We wanted to make a different change to this file. So, what do you think I would need to do?
Get check out.
Well, no, you have to.
Get it. Well, make a change in the document first.
So checkout.
Get reset the head.
So difference between checkout and reset. Checkout will put your head there, and nothing else. If you do checkout -- hard, it will put your head there and set all of those files to the state that they were in back when you were there. And then get reset will do the same thing. It will put your head there, and it will reset all of your files. Plus, it will move the branch that you're currently on, which is master. So this is another thing to be aware of. Git is stateful. So if you get into a weird situation, like remember to do a git status. Because like the state here is I'm on a branch. There could be a bunch of other branches here. I'm gonna call this one S, but like it knows that I'm on M. And so special operations like checkout will move the branch that I'm on around, but leave this other branch that's also pointed at the same commit completely unaffected. So of those three commands, how would we want to get back to this commit so that we could branch off of it?
Let's try checkout.
Yeah, checkout sets your files and takes your head. Git, checkout. And the syntax does not matter. Like if you know what you're doing to the graph, if you have this vocabulary, you can just Google like git previous commit, take head with me, and like you'll probably end up with like the Stack Overflow page that tells you, oh, you went to checkout -- hard, FE11857. So this is another important thing to say. You can call commits. It doesn't like you could. These labels are just for us. Like you could like wipe all these labels off and still like do everything that you can do today in Git. So I can check out this branch by its commit hash, a SHA. I can check it out by any tag or branch pointing at it. Or I can use this handy syntax and say head ~1, which means go to my head and like subtract 1 from it, and then whatever commit is there, that's what I want to check out.
So what's the -- hard?
Well, let me make sure that it works first before. Unknown option. Oh, is it hard? No. Is it just ~1?
You do it before you.
Yeah, reset. It's reset head hard. Sorry. See, I don't like for one. Usually, I practice this a lot the night before because like I never use the Git command line, and I become like an expert on Git command line for like one day, and then I forget it all. Like, I don't have room in my brain for this stuff. I usually just use IntelliJ's like built-in graphical like Git tool. It doesn't matter what interface you use. Like it matters that you know what you're doing. So the commands are kind of arbitrary. So if I type git Lola, Who feels kind of confident in this one? I think we're weird. What did we want to happen, Chance?
We wanted to move the head down to the master. Or wait, sorry, I said that. Yeah, just the head down to that first.
Yeah, so I believe we wanted to keep master, but just
Right.
move the head. I think this is what we just did. Yay! Look! See, I didn't even practice, and I don't know, and we're fumbling our way around Git.
So head is what you're going to see. Is that?
Yeah, so if I cat this file,
Project, then you'd be seeing head.
head tells me like what is in, like whatever the state of my disk is now is like whatever was at that commit. So look, Git also warned us, you are in a detached head state. That sounds scary. It's warning us like there's no human read. I can keep committing on top of this commit, but like if I go check out master again and I want to get back to here, what did I do? Like memorize my SHA? Like hope you did. I'm actually lying. Well, gosh, so much to talk about. So these commits are called orphans. Like any commit that isn't referenced by a branch or a tag, or transitively through another commit that's referenced by a branch or a tag. It's like, this thing is, there's a command called like git gc, and that stands for garbage collect. This is the only way you could ever lose anything you've committed to Git. Like pre-commit, you're on your own, you're just in the file system. But once you've done a commit, it's in that graph database. Even if it doesn't have something pointed to it, it's still there. The only way is like if I had a branch, and then I deleted that branch, and then I ran a git gc command, then it would find all these orphans and kill them. And they would be gone.
What else all the orphans?
Unix terminology is actually surprisingly full of lewd jokes and innuendo. Sorry, I didn't write it.
Yeah, Linus is kind of good.
Well, this is Unix, going like back to Bell Labs and AT&T and stuff.
Oh.
So, so that isn't true that you have to write down the name or the SHA of the commit, because I can actually do this other thing, git reflog, and that's just going to spew out like everything I ever did in Git, including the hashes of these commits. So if you can go back and find the hash of the commit of the branch you deleted and you have not run git gc, you can just check out a new tag, a new branch pointed at the commit, and boom, you're back. So you never lose work in Git. So like next lesson here, don't panic. Like when you're like, oh no, I think I lost work. I'm in a weird state. I don't know what's going on. I'm gonna like run some crazy command that's gonna like nuke my hard drive or like overwrite the, no, just chill out. Chill out, it's all there. And like given knowledge that you know today, like it's just a matter now of Googling for the appropriate command. Which if you use these terms like branch and commit and tag and checkout and reset, like you can Google that and figure out what you're doing. Yes?
Can you explain master and head and like what, like they're just tags, but like what do they signify like on your like tree?
Head is a special tag where whatever commit that head is pointed at, in this example, FE is like what you see on your disk. Like those are the files that are sitting in your directory. Does that answer your question with head?
Yeah.
Okay. Master is just like it's like another piece of state. Like every Git repository has like a main branch, and by default this is named master. Like you can go and rename that to something else, and that's just the default really. It's no really any different than any other branch. In fact, I'm not even sure it's like the main branch in Git, because like in GitHub is where you set it. So I don't even know if there's a notion of that being the main branch in like the command line Git. It's the default. When you say get init, you get a master. But we want to make a new one. So so what I want to do is not be in a detached head state. What do we want to call this branch? I'm going to call it B. I don't know, A. I don't have a lot of room on this board, so we're going to go with A. How do you think I make this happen? Not Chance. Somebody else. Okay, Michael.
I think you do git checkout -b.
Yes, so this is another lesson.
-- branch works too, right?
Linus did not write the syntax for the command line of Git to like make a good user interface, Linus wrote the commands to do like what they do. So you can do like git branch dash dash new or something, and it will like make a new branch, but it doesn't even like make it pointed at the commit that you're on. You have to like tell it. So usually what you want to do, or no, it'll make it, but it won't check it out. It won't set your current branch to be that thing. So like he, for some reason, thought it would be cool to make the syntax git checkout dash b. So like check out a new branch called A. Thank you. All right. So git Lola. Yay, we predicted it. Head is pointed. So by the way, that's yeah. So head is pointed at A, and E is pointed at this thing. So now, yeah.
We gotta go. 84 is lightning talks.
But I used to be 420. Now, and then I thought it was 4. Now it's like 350.
Our instructor said 350.
Yeah, these guys can stay though.
All right. Well, I'll watch the recording later.
Thanks.
My pleasure. Oh, sad face. Check the learning objectives. What's a DAG? You can't leave.
Direct, acyclical graph.
Yay! All right. Win for the teacher. Checking objectives, even when your students are running away. Booyah. Cool. All right. So what do we want to do to this, real quick? I'm trying to go a little bit faster since we only got like 12 minutes.
Create a file.
Create a new file. Cool. Echo new file into new file text. Going fast, getting uncreative. Dot git commit dash m. Okay, what will git Lola look like? You break it, you bought it.
Well, it's gonna have a little branch coming out the side.
Okay, so there's a commit. It's going to have some kind of SHA. What tags will be pointed at it?
The head and the A will now be over there.
So your theory is the head and the A will be over here, which means they're not here. Does anyone disagree with Michael or have another opinion? This is your chance to make him look
I just
bad.
do them on a regular basis, but not right now.
Head and A are pointed at new commit, which is diverged from master. By the way, that's the word. These two branches have diverged. This commit is like one ahead of master, and this is one ahead of master, and so yeah, those are the words. Remember those? Like ahead, behind, diverged. This is the common ancestor. There's a commit there's a command you can run in Git to like trace back and find the common ancestor of any two commits that have one. And cool, now we've got the hash.
So if you checked out the master,
Hang on, we'll do it.
okay.
6672554B. All right, so that was Chance. You're
Yeah, I was gonna say if you check out the master, what it's basically when you do Lola again, is it gonna switch those top two?
well. So what does checkout do?
It's gonna
Using our vocabulary,
it'll take your head over there.
it'll take your head over there. So it will point head at the branch called master, which is pointed at this commit. Head's pointed at master, which is pointed at this commit.
So it keeps A up there because it's more recent?
Oh, don't ignore. Like,
Okay, okay.
maybe it's doing it based on time.
I think it's just a display issue. Like it's just they can't really put them side by side without doing weird looking
Exactly. The graph has no notion of which is ahead or behind. It's just
Okay.
there's 2 edges and 3 nodes, and there they are.
Okay.
By the way, that line, an edge, asterisk, a node. More academic language. Cool. So next, what do we want to do? You're not gone yet, Brandon.
I don't know. What do we want to do?
I want to make a conflicting change, because let's talk about conflicts.
Oh, okay. Yeah.
Yeah, do that.
So yeah, do something on this overwrite. Yeah, there we go.
Oh, but will that conflict? Because we haven't touched master in the other one. So this will technically be a non-conflicting change.
Oh, we're in master.
Git is great at, like, unless you touch the same line in 2 files, you'll not have a conflict.
Yeah.
But we did change this file in master, right? That's what our second commit was. So let's go check out A, and let's overwrite that. So now we've changed README in both A and in master. So if I do git Lola now, what happened? I was on this branch and I made another commit with a conflict to the file in master. Yeah.
Two commits ahead of.
So we'll be 2 commits ahead, all right, and then this will have some kind of SHA, and then where will head and A be?
You're at head.
That will be the new node.
Will be the new node, and A will be,
Does it save spot then? Or, oh no, we'll leave that node.
yes, a branch follows. If we had tagged this,
Ah, yeah, that's making more sense.
if we had set a tag there, it would stay behind. The branch that we're on will follow us automatically. If we had other branches there, even if I had a branch B and A pointing at that, but I was on A, then my A would go forward and my B would stay. Cool, we have some predictability. Head and A have moved on, and now we've got a SHA, which is, read it to me.
9D88163.
So far we haven't needed these, but sometimes it's important if we want to like delete branches and show how that works. All right, so now I want to get my work back into master. It's like, so one of my colleagues has done some work, now I've done some work. I've like pulled this down. We're on a feature branch, like we were on feature A and we were like doing our work. This is the exact same thing. Like you can diverge from origin master. Git is a distributed version control system. So like all that GitHub is like one of these giant databases in the cloud. So it's got your graph. And then on your computer, you've got the graph. And so this is important. So you can add as many remotes as you want, and you can give them whatever names you want. So the default name for a remote is origin. And so that's why you git push origin space master. You're saying push to the master branch on this remote called origin. But then when you can do 2 things. You can fetch, and all that does is you have like a copy of origins. So here there's an origin. It has a branch called master. You locally, when you fetch, you make a copy of origin master. But that is not the same as your master. There's two separate branches here, both pointing into this graph database. So if you just fetch, all you do is like go over the internet and update where your copy is at. If you could then merge origin master into master, and now you'll be up to date really with what's there. And a pull is really just an alias for both of those things. You're doing a fetch and a merge. And like the counterexample for push. So you have a whole copy of all of your remotes, and that's why here the name of the remote is origin. So when you're doing stuff with it, Git uses spaces. But when you're talking about this branch, that's a copy of what is in origin, it uses the slash as if it was like directories. So this is the same as that. Except when you fetch, which makes this the same as that. That's what fetch does. All right, so we have a conflict. We are on branch A.
It should be A.
This should be A. On branch A. And now we want to have all of the changes. What do we do?
So you're saying we want branch A and branch master to
I want
be one and the same?
I want all 3 of these, the commits from all 3 of those changes. What can I do?
So when you're in the head, maybe just the git push master.
Nope, we're not doing anything. We just have a local repo here, and I'm not going to push it to GitHub today.
I think you want to go back to the master branch because that's the destination you're merging to.
Like I want to merge my feature branch into master.
Is that what we're attempting to do?
Sure, yeah, let's do that. So we're going to check out master and do a git Lola. So I encourage you to like do this often. Like if you don't know, git Lola, look at the DAG, and then you'll figure out what to print. All right, so we're in master. How do we get the changes from A?
Git merge A.
Okay, and that will create a commit with how many parents?
2.
All right, so we'll have a new commit with 2 parents. And this is a special type of commit called a merge commit. Next time we get to do this, let's do a rebase instead. And you'll see how to like, we've created a DAG here, but like simpler is always better. I prefer a list. There's commands in Git that you can't run, like bisect, if you've got a DAG. But you can use these helpful commands if you've kept it into a list. Some of the largest software projects on Earth keep everything in one long line.
Do they have branches that just like they just pull back in?
So what you do is rebase, so like take these commits and like play them as if they were on master, resulting in entirely new commits with entirely new hashes, and then move your head in that branch name up to here. So that's how you do it. And since these are immutable, those ones will be hanging out there forever. So it's kind of like rewriting history. So like you want to be careful with how you do that, but done properly, it's a nice, clean, long line. Next lesson, but I think like you're already getting it to the point where like if you understand this graph stuff, like, oh, I got rebase. Cool, thanks. No, I don't need a lesson on that.
So you're gonna get rebase A.
I could get rebase A. What do we want to do? A rebase? Let's do a merge. Keep this simple. Conflicts. Oh no. Like what happens when I have conflicts? I can like cat this README file and like see what's in it. Oh no, like arrows and equal signs. Like this is confusing to me. I don't like that. So I just do like git merge tool, and then this pops open like my favorite merge tool, which is meld. Not really, but whatever. You need one of these things. Like not only you need a way to visualize the graph, like git Lola, and you need a merge tool.
Is meld really your favorite?
No, it's just a handy one that's available on like most open source operating systems. So I'm going to resolve this conflict graphically. I can do whatever I want in the middle. That will be the result. And now I can do save, I guess, maybe. So git status says, hey, look, changes to be committed, new file. This is one of those stateful things I was talking about. All conflicts fixed, but you are still merging. I'm in a merging state. Like all of my commands will have a different meaning until I either do a git merge abort or a commit.
Hey guys, we're still doing a breakout.
Yeah, so if you could just hold on for like 30 seconds, I'll be done. So git status, I wanted to get rid of that other file. I've got this one. So changes are about to be committed, so I guess I just do a commit-m merged. So now if I do a git Lola, we should see. Hey! All right, there it is. That is how you get. If you can do git Lola and then predict the command and then predict what you're going to see after it, then like you are a Git Kung Fu master. So try that out. I can slack out like a worksheet where you can follow a tutorial where you follow along and do all of this stuff at home. Thank you very much.
Do you have any other merge tools that you